Hello everyone, I hope you're doing well. In this video, we are going to find out the structure factor for NaCl. Alright, so NaCl is also known as rock salt. Whenever they ask you to find out the structure factor for rock salt or NaCl or sodium chloride, it's the same thing. So let's quickly get started and see how we can do that. This is a requested video. One of my subscribers asked me to upload this video, so here we are doing that video. First of all, let us understand the structure of sodium chloride. It's a quick overview. We don't need to understand it in depth because that is not required in this question. So here we have sodium ions which are in gray color here. These are sodium ions, while the chloride ions are in green color. You can see the bigger atoms are chloride atoms and the chloride ions, and the smaller gray atoms are the sodium ions. Here what happens is that chloride ions have their own FCC structure. Okay, we have these bigger atoms. You can see, only imagine these bigger atoms and imagine that the smaller atoms doesn't exist. So if we consider chloride atoms all alone, they are making a FCC structure. So the ones that I shaded here, okay, these are the corner atoms of this cube, okay, and they're all chloride atoms, okay, and these are the corner atoms, 4 above and 4 below. Now I'm gonna highlight, okay, the face centered atoms. This is the left face centered atom, this is the right face centered atom, this is the backward face centered atom, this is the forward face centered atom, this is the downward face centered atom, and this is the upward face centered atom. Okay, these orange ones are the face centered atoms and these pink ones are the corner atoms, and these are chloride ions. And you can see here that the chlorine itself is making a FCC structure separately. Alright, and the same goes for the sodium ions. Alright, sodium ions are also making a FCC structure, and we can see here that this is the sodium ion corner atom. These are the corner atoms, and you can see that this is the sodium ion in the face centered position. This is the base for the sodium lattice, I would say. Okay, and you can see this is another face centered atom. These are other face centered atoms. So we can see here that we can see the base of the chloride FCC is here, while the base of sodium FCC is one step up. You can see here, okay, it's here. We can see this is the center atom, while for the chloride ones this is the center atom. If you're getting confused, you can don't be worried here, just I'm explaining if anyone is concerned. Alright, so I'll not elongate that explanation because it's the matter of another video where we'll be understanding the structure of NaCl. However, this is really important to realize that how the NaCl structure is FCC. Okay, we can see here, like we can justify here really easily that chloride ions makes a FCC structure while sodium ions makes a FCC structure separately. Okay, so they both are FCC structures merged together. Alright, so it's like NaCl structure is actually two FCC structures merged together. Alright, so that is what the NaCl structure is. Now let's see what are the positions, what are the formulas that we will be using to find out the structure factor for NaCl. Okay, so other than that, I'll not add any other information here because I know that you will be confused, you people will be confused, so that is not needed here. Till that point we are just understanding that both of them are FCC. Okay, and first of all, let's write down the formula that we are going to use to calculate the structure factor, because it will help us to know that which things we need to insert in order to calculate the structure factor. So the structure factor is given by, we'll write it down here, structure factor is given by okay, let's write down the formula. And structure factor is represented by capital S, okay, and we can write in subscript the Miller indices of the plane, okay, because structure factor ultimately depends upon the Miller indices of the planes and also on the atomic form factor, but HKL as well. And that is equals to, we write it to be equals to summation starts from J equals 1 to capital N F J F. This F is atomic form factor and it includes the atomic, contributions by the unique atoms that are present inside the unit cell. For example, it's different for sodium and it's different for chlorine. This is because the electronic cloud of sodium is different from that of chlorine. They have unique electronic cloud and they diffract or scatters the incident X-rays differently. So their capabilities are different, and hence we differentiate the capability of each atom through this atomic form factor. Alright, so this atomic form factor corresponds to the unique electronic cloud that each atom has. So we will encounter that and we'll see that how we'll denote it. It's just a symbolic thing right here in this question. And Fj times, we have an exponential factor e to the power 2 pi iota times we have hxj plus kyj plus lzj, okay, where xj, yj and zj corresponds to the location of atom that you are considering. So we'll see how we apply this formula, and this is the general formula to calculate structure factor of any unit cell that is given to you people. Okay, so let's see what happens in NaCl, how we can find out the location of all the atoms that contributes towards that appear as the net contributions inside the unit cell. So let's see how we do that, and after that we'll be able to solve the question. So that is it what we have so far, and let's see the structure of NaCl now. First of all, we saw that Na has a FCC structure, okay, and chlorine also has the FCC structure. So first of all, we'll see the positions of sodium ions, and then we can find out the position of chloride ions. And if you remember that FCC structure, in FCC structure we have 4 net atoms, okay. In simple cubic we have 1 atom per unit cell, in BCC it's 2 atoms per unit cell, and in FCC we have a net of 4 atoms per unit cell. And we have also seen that what are the permittive vectors. So here I'll tell you that how we calculate that. We will take this point, this sodium atom, as reference, okay, and we will call this atom to be at origin. Okay, we'll consider this atom, this is one of the atom. We have 4 net atoms, we'll select 4 atoms here, and we'll select 4 atoms location here as well, and I'll tell you that how we choose those locations. And similarly, since chlorine has also FCC structure, so we will be choosing 4 atoms here as well. We'll choose their location, but first let's do it for sodium. And for sodium, the first atom I'm choosing at origin, okay, this is at origin, so its coordinates gonna be 0 0 0, and this is x-axis, this is y-axis, and vertically upward would be z-axis. And also keep that in mind, what I'm collaborating here is that from this corner atom to this corner atom the length would be 1, okay, from one corner to the other corner ending at the similar atom. For example, if I'm starting at chlorine, so I'd be ending at chlorine, so that's gonna be this whole length, this length would be taken as 1. But if I'm from sodium to chlorine, the length would be half. It's like the distance between 2 unlike atoms would be taken as half, while the distance between 2 like atoms would be taken as 1, okay, and it's along the axis direction. So that is how I will see that why it matters is because it matters while finding out the coordinates, and we will see that how we do that. So we can see this is the first atom that we chose, and the second atom should be on, this is the atoms that you choose should be the nearest neighbors on xz plane, yz plane and xy plane. Okay, we have chosen origin here, so we will choose the nearest neighbor on xz plane, yz plane and xy plane. Let's see what does it mean. So if I talk about the xz plane, so it means the side which is across this z and x. This is the side where it's x and z, okay. So this is the sodium, and the other sodium atom that is nearest to it is this sodium atom. So this is the sodium atom on the xz plane. All right, the next should be on yz plane, and if we see the yz, this is the y direction and this is the z direction. So this plane is yz plane, so we'll be choosing a atom on the yz plane, and this is the one, and on the yz plane this is the atom. Okay, this is the nearest atom on the yz plane. This is on the front. This is the atom when you move like here, here and here. Okay, this is the farther atom. So if you are getting confused here, don't be confused. I'll let you know that what you can include in your exam solution. Okay, so this explanation is for those students who are curious that how we are choosing those atoms. Well, so far we have chosen 3 atoms. One is here, second is here, third is here. We need to choose one more which is on xy plane. So we can see this is x and this is y plane. So this is the atom that we are gonna choose. This is the atom on the xy plane. Alright, so it's just like we found the plane and we chose the centermost atom. Alright, so in this xy plane we can see the center atom is here. Okay, in the xz plane, this is x and this is the z plane, the center atom is here, the sodium one. And for the zy plane you can see this is the z and this is y and the center atom is here. So we simply choose the center atom to each of the combination of the plane. Okay, now let's see what are the location of these atoms, because the first atom is at origin. So where is what is the location of the other 3 atoms? So let's find out the location, because that is what we will be inserting into our formula. So let's write them down here, and this is the first atom and the second atom. Let's see where it is, and starting from origin. Okay, let me simplify this diagram because it's so much crowded. And yes, this is x direction, this is y direction, and this is the z direction. So this is the origin, and we will start moving from origin. And this is okay, we'll start moving from origin, and from a sodium atom to chlorine atom it's half distance. Okay, we moved half along x, then half along y. Okay, this is half along y. If we draw the straight line, this is half along y, and we reached this atom. Alright, so why half? Because it's we are traveling between 2 unlike atoms. If you are traveling between 2 unlike atoms, it's gonna be half. So we moved half along x and half along y and 0 along z to reach this atom. Okay, that is the second atom. Now arrangement doesn't matter if you find out coordinates of this one first or this one first. That doesn't matter. Okay, don't be confused in that respect. So now let's move from origin and reach to this atom that is here. So starting from origin, I'll move half unit along x and then half unit along z to reach that point. So half unit along x and 0 unit along y and half unit along z to reach that point. Okay, so this is the coordinate of this one atom, and we can see we moved between unlike atoms here, then between the unlike atoms again in the z direction. And also keep that in mind that you have to move along the x, y or z direction. Okay, you don't move in diagonals, you only move in horizontal lines along x or y or z. So it's like you move in that respect, not like you are moving directly like that. That is not permissible. You are not supposed to move like that. So let's find out the coordinates to the other one. We can see that here we are, and we'll move vertically upward between unlike atoms. So we moved half unit along z and half unit along y to reach this location. So it's half unit 0 unit along x, half unit along y and half unit along z to reach this point. So these are the coordinates of the fourth atom. So for chlorine, for sodium, we can write the 4 atoms are located at these positions. So we write it like that, 0 0 0. Okay, here I'm gonna mention the trick that you can remember without drawing the unit cell. Okay, you can remember these coordinates really easily. So what happens is that we have 0 0 0. First we'll write half and half, 2 halves for 2 of the for x and y we'll write half and 0 for z. Okay, then we'll write half here, then 0 here and half for the next one. Like we will write half for the 2 axis lines at a time and 0 for one. this is the code. So since it's half, half, 0, half, 0, half, so last would be 0, half, half. So in that way you can remember it as well. It's really easy to remember. We'll have 2 halves and 1 0 at a time, and this one will be at origin, so all of the coordinates will be 0. So these are the coordinates of atoms that we will be having in the formula. And let's do it for chlorine now and see that how we can do it for chlorine, since we have calculated it for sodium successfully. Now let's do it for chlorine and see that how we can do that. For chlorine, it's again the same thing that we have for chlorine. We will have 4 chlorine atoms, so we'll choose 4 chlorine atoms. So for sodium we chose this point, but for chlorine we'll choose this point. But again, this is taken as origin. We'll take the same point as origin. This is the origin for us again. So this is x-axis, this is the y-axis, and vertical, yeah, that is the z-axis. Alright, so that is the z-axis. Now let's choose the chlorine atom. So we can choose it directly, like this is the chlorine atom, and let's choose the nearest most neighbor for it. Okay, so and they are the ones lying on the center points. Okay, we'll choose the center ones, not any other, but the ones which are located at the center. So for the xy plane, this is the xy plane, the center atom is here. Okay, the center atom is here, the center chlorine is here. YZ, the center atom is here, the closest atom to this one atom. Okay, so this is first, second, and third. Let's see what should be the fourth one. This one, yes, this one is the closest one. Other than that, all of them are the furthest one. So these 4 will be chosen as the atoms that would be representing the chloride FCC structure. So let's write down their locations with respect to that origin, this origin. Okay, this sodium atom is taken as origin. So let's find out the location and see what are their coordinates. So let's find out the coordinates of this one atom first. So from starting from sodium, we will move half unit along chlorine. Okay, half unit along Z to reach this chlorine atom. So we only moved along Z and we reached that point. So it's 0, 0, and half. Okay, now for this atom, what we do is that we'll move only along X and by half unit to reach that point, because we moved from sodium to chlorine between unlike atoms, so it's gonna be half unit. So we found its coordinate as well. Now let's find out coordinates of this one. So we'll move only along Y, half unit to reach this point. So it's 0, half, and 0. We can see here one pattern that we have 2 zeros at a time and 1 half for one coordinate. So we'll just shuffle the position of half and we'll get its coordinates. It's a simple trick to find out the coordinates real quick without drawing the unit cell. But obviously, as I'm explaining it to you, I need to show you the complete method. So for this one atom, what we are going to do, this is located at the center position. So to reach this atom, we'll move half unit along Z, then half unit along Y, and then half unit along X to reach this point. So for this one, it's half, half, and half. Okay, all of them are half. And okay, you can see here this pattern that we have half, half, and half. Okay, all of them are half, just like here we have all 0, we have all half here. And okay, now we'll shuffle the position of half. So we have half and then 0, 0, then we have 0, then half, and then 0, and then we have 0, 0, and half. Okay, that is how you can easily find out the position vectors of sodium and chloride ions in NaCl structure. Okay, they represent in net, they overall represent the 4 net atoms in their FCC structures. So now we can use these locations and we can write down the structure factor for NaCl. Okay, for NaCl we have Na and Cl, so we needed to have position vectors of 4 atoms in NaCl in Na and 4 atoms in Cl, you know, to find the structure factor. Now let's apply the formula, and first of all we write down for sodium, and then we'll write down for chlorine, and then we'll add them up to find the net structure factor for sodium chloride. So first we'll write the structure factor for sodium ion, and that is equals to, we will have this formula like we have J is equals to 1 to capital N, and we'll have F and A because we have sodium atom, and then we have exponential factor 2 pi iota, and then we have x hxj plus k yj plus lzj. Now let's apply all of these things here, and let's put the values. And here J equals 1 to N. Capital N means the total number of atoms that we have in here, so instead of capital N you can write 4, because we have 4 atoms in NaFCC structure, so we are writing it to be equals to 4. So let's write it down. We can take F and A outside of this summation because all of the atoms are Na, so that doesn't matter now. And let's write down this factor for each of the atom. Okay, so for this atom, for this atom, and for this atom, for this atom. Okay, we'll just put, instead of x we'll put this, y instead of y we'll put this, and z. Okay, this is how we are gonna put. So we'll put it separately for each atom. First, for first atom we'll do it. Okay, 2 pi iota, and then we have this h. Okay, h will come as it is, x is 0 plus k, y is 0 plus l, and z is 0 as well. This is for the first atom. We can use this bracket. Okay, this is for the first atom which have all of the coordinates 0. Next we have half for x, half for y, and 0 for z. So we'll put here, okay, we will use the plus sign, and we'll insert for the second atom, and it's gonna be e to the power 2 pi iota, and h times half plus k times half plus l times 0. Okay, that is for the second atom. Now let's do it for the third atom, which is half, 0, half. Okay, half, 0, half, e to the power 2 pi iota, and it's half, 0, half, so h half, k 0, and half. Alright, so let's do it for the last one, which is at 0, half, half, 0, half, half, so 2 pi iota, h 0, half, half, so k 1 by 2, l into 1 by 2, and yeah, and we can close this bracket, this bigger bracket that we started here. Okay, this bigger bracket like that. Alright, now the next step is to simplify it. Let's simplify it and see that what we are gonna get. Okay, so let's simplify it. So we will have F and Na in its subscript, then bracket starts, and let's simplify. Okay, e to the power 2 pi iota, we can write it like that, 2 pi iota, and after that we have h into 0 plus k into 0 plus l into 0. It's 0, 0 plus 0. Okay, 0 plus 0 plus 0 is 0, so 0 is being multiplied here, so plus sign, and then we have e to the power 2 pi iota, and then we have h by 2, h into 1 by 2 is h by 2, then we have k by 2, and then we have l into 0, which will become 0, so we don't need to write that, and that is it. Okay, so next we have simplified this term as well, so next we have this term, so we'll write e to the power 2 pi iota. Okay, then we have h by 2, this becomes 0, so we have plus L by 2. Then plus sign, we have the last term here, which is e to the power 2 pi iota. Okay, let's 2 pi iota, and h into 0 is 0, so we have k by 2 plus L by 2. Okay, so in that way we have successfully simplified this situation, and now simplify it even further because we know that we can do that. So that is equals to FNA into e to the power 0, because this 0 multiplies with whole quantity and becomes 0, so e to the power 0, which is actually equals to 1. You can do it on calculator. So now here we can, you know, take this 1 by 2, this 1 by 2 common, so it's 2 pi iota by 2 into h plus k, plus e to the power, here again we can take 2 in the denominator outside, so we have simplified form h plus L, and plus in the last term again we'll have the similar thing, 2 pi iota by 2 into k plus L. Alright, we can close this bracket now. Here we can see that this is equals to 1, and this 2 and 2 cancels out, this 2 and 2 cancels out, and this 2 and 2 cancels out, and we will have a simplified form. Let's write it down here. That is equals to FNA into 1. Okay, this is 1 plus e to the power pi iota into h plus k plus e to the power pi iota h plus L plus e to the power pi iota k plus L. Alright, we can see here that we have got a really simplified formula now, and this is the structure factor for sodium part only, and we need to do it for the chlorine as well. And let's see that what we will get for the chlorine, and after that we'll sum it up for sodium and chlorine and part by sodium. Now let's do it for chlorine, and we can see that what we will get. That is equals to summation j equals 1 to 4. Okay, because in chlorine we also have 4 total atoms, so F and chlorine here, and then we will have this exponential factor 2 pi iota and hxj plus kyj plus lzj, and let's do it. Let's insert those values and see that what we are gonna get. So SCl minus, that is equals to FCl. We can take it outside because all of the atoms are chlorine, we know. And okay, so 2 pi iota, first insert the value, these ones, this is x, y, and this is z. So it's gonna be h by 2. Okay, we can simplify, like x is 1 by 2, so if it multiplies with h, it's gonna be h by 2, then k by 2, and then l by 2. Alright, so next term plus, okay, next term is half for x, and these two are 0, so we will only have h in that way. So it's e to the power 2 pi iota, and it's half for x, and the other two are 0, so I'm not writing them because we don't need to. Okay, we know that all of them are 0. Next we have the y, which is non-zero, and these two are 0, so we'll have k by 2 only. So we'll write e to the power 2 pi iota k by 2, then plus sign, and we can see the last one in which only the z1 is non-zero, so we'll write it e to the power 2 pi iota l by 2. Alright, so let's simplify and see that what simplification we can do here. This 2 and this cancels out. Okay, these cancels out, all right. And also if we take these two common, this two and all of these two will cancel out, so we will have this simpler situation: e to the power pi iota, then h plus k plus l, and plus e to the power pi iota h, okay, only h is left, e to the power pi iota k plus e to the power pi iota l. That is what we are left with for now. And in next step what I'm gonna do is that I'll take e to the power h, okay, e to the power pi iota h plus k plus l. I'm gonna take this whole thing common, and it will enable us to have this first quantity as 1. Okay, since we can see that here we had 1, and I wanna create a similar kind of situation here, so I'm gonna take this thing common. And okay, let's do it, and let's see how we will get a simplified form. Let's see L minus, and I'm taking we don't need to write ein here because we are considering the atom in it. So yes, so that is equals to 2 pi iota h plus k plus l. Okay, I'm taking it as common, so we will have, by taking common we mean that we are dividing this quantity inside. So in case of exponentials, we can see the power will be simply subtracted from all of them, so we'll subtract the power. So this is the first quantity will be 1 obviously, and the second quantity is e to the power pi iota h, so it's pi iota h, and that will be, this power will be subtracted from it. And okay, let's do it the simpler way if you are getting confused. So it's simply like we will divide this quantity with each of the quantity inside. So the first quantity simply cancels out, so we have 1 in the first quantity. So let's do it for the other ones: e to the power pi iota l and divided by e to the power pi iota h plus k plus l, and plus e to the power pi iota k, and that is divided by e to the power pi iota h plus k plus l. Alright, so now since we can see that the bases are same, so the powers, we can see the base is e here and the base is e here as well, so we can subtract powers when they are being divided. Okay, so we can see that both of these quantities are being divided, so we can take this out upward and we'll subtract that from the upper power. Okay, let's do that here and see how we can do that. And that is equals to f cl, and e to the power pi iota h plus k plus l will stay the same, and we have these inner quantities now, and that is 1 plus e to the power pi iota h. Okay, then minus sign, and we'll subtract these ones now, and I'll multiply pi iota with each of these quantities. Okay, I'll write them separately, and also let's multiply negative sign inside, so it's gonna be minus pi iota h minus pi iota k minus pi iota l. Okay, we can simplify later in next step. So then we have e to the power pi iota l, and it will be subtracted pi iota l, sorry, h pi iota l pi iota k. Okay, we can understand. Okay, the last quantity here, let's write down the last quantity, which is e to the power pi iota k minus pi iota h minus pi iota k minus pi iota l. All right, this is the situation so far. Let's simplify further and see what we are left with. Okay, so we can write scl minus equals fcl, and e to the power pi iota h plus k plus l. Alright, and this bracket, bigger bracket starts, and let's write down these terms, and it's 1 plus, now this pi iota h and pi iota, these cancels out, and the other two left behind, and we can take minus pi iota common, so it's minus pi iota into h plus k. Sorry, h की कर दी पई, it's k plus it's k plus l, minus pi iota k plus l. Alright, so next one we can see here pi iota l, and this pi iota l cancels out. We have pi iota h and pi iota k. I'll take minus pi iota common, so we are left with h plus k. H plus k, this is in the power, so plus pi iota k, and pi iota k cancels out, and we have minus pi iota h and minus pi iota l, so we can take minus pi iota common, and we are left with h plus l. Alright, so we can close the bracket in that way. Alright, so we have got a really simplified form, okay, and we can simplify it even further. Like we know that e to the power pi iota, that is equals to e to the power minus pi iota. Okay, so we can simply replace e to the power minus pi iota with a positive, because that doesn't matter. Safely do that in trigonometry. So we have this connection, so okay, we need to write it down here as well. So we know that simply exchange that, so we have these plus ones. Okay, you need to write it down in the next step. So that is what we have got. Alright, and if I recall, and if I write down the structure factor that we got for the sodium part, let's write it down here so that we can have a side-by-side comparison as well, and we may see. Okay, that is here, and let me take it. Okay, that is the one for sodium, and we can see a good comparison. Like we can see that this whole term in the bracket, these bracket terms in both of these cases are completely same, and yeah, it's like we are almost done. The solution is almost done. Now we just need to add these up, and now structure factor for sodium chloride is given by factor for sodium chloride NaCl is given by, we have structure factor of NaCl, we can write it like that to show that it's for NaCl, and S for Na plus S for Cl, and let's add them up and see that what we are gonna get. The structure factors, okay, we can do it in here. You have to do in next step, like you will add them up. I can do it here because I have already written them. So it's simply these two quantities being added to each other, and we can write a plus sign here, so they are both adding with each other. Now we can see here that we have this common factor between these two quantities. Okay, so we don't need to write them, two times. We can take it common and we can write it like that. Okay, let's write it here. So yes, let's write it here, and we can take this whole quantity common, so it's gonna be 1 plus e to the power pi iota h plus k, okay, plus e to the power pi iota k plus l. Is just like there's summation for all separate cases, so h plus l. Okay, so I have written it one time here. Okay, this whole quantity is now written. I have taken it common, so now I'm gonna write only FCl, this quantity, plus FNA only. So we will write it, we'll close this bracket, and we have this thing multiplied by, we have multiplication sign here, and we'll write FCl e to the power pi iota h plus k plus l. and plus F and A, bracket closed. Alright, so this is the final expression for the structure factor of NaCl. Alright, now it's the time to make comments on the factor that we have got. Let me write this whole thing into a single line so that you can have a better idea about how it looks like. Well, we can see here that I have written the whole formula, the whole result in a single line. Alright, and we can see here that this is the final formula for the structure factor of NaCl, and we can see we have two different factors. One factor which depends upon the atomic form factor and the Miller indices of the plane, and the other factor which only depends upon these factors. Alright, so as we have found this value, now let's see that what we can expect, like what kind of values we can get from it for different HKL values, like different HKL planes. So here we will have two categories. One is the mixed values of HKL. We'll see what does it mean, and the other is unmixed values. And by unmixed values, it means that at a time either all HKL values are odd, all odd, or all even. Okay, this is the situation that we call as unmixed values. So it's like all of them are odd. For example, if they are HKL values, let's say they all are odd, like 333 or 3 5 and odd values. Okay, odd, this is odd as well, right? So it's like if you get these Miller indices where all of them are odd, so this is unmixed value, all odd situation, or all even, like 246 or 222 or 248, something like that. These are unmixed values. So in that case we get different values. And for mixed values where we have mixed situation like 269, 362, this is the mixed values. We see that why we categorize it like that, because it's similar to FCC structure, and in FCC we got the similar kind of result. So we have two scenarios, either we have unmixed values or mixed values. And why that matters, let's see that why I categorize it like that. We can see that we have H plus K, K plus N, and H plus L. Now let's suppose that we have all odd values. So what happens is that, let's say we have 3 3 3, all are odd values, is the simplest case. So we can see that H plus K, and then we have K plus L, and then at the end we have H plus L. If you find out their sum, it's 3 plus 3, that is equals to 6, 3 plus 3, that is equals to 6, and 3 plus 3, that is equals to 6. We can see that odd values add up to give a even number. We can see that only two of them are adding to each other. So two odds, when all of them are odd, odd adds to give a even number, and even numbers adds to give a even number. So what happens here is that if we have 2 pi iota times even number, then it is equals to positive 1. Alright, and if it's odd number, then it is equals to negative 1. And it leads to overall, if we have the mixed situation, we'll see the answer that we get here would be equals to 0. We'll see that all of these values cancel out each other. So we'll see that case. But for the matter of unmixed values, we can see that if we have all odd and all even situation, we will get 2 pi into even powers in all of these quantities, and we'll get 1 plus e to the power, this quantity will become 1 from this reference, because they all add up to give even values. So we have this situation satisfied. So it's 1 from this quantity, and 1 from the third one, and 1 from the fourth. So we get total of 4 sum. We total of get 4 instead of this value. Okay, let me do this in neat form so that you are not confused at all. So let's do it here. Alright, so we can write here that if we have 2 pi iota times a even number, okay, if we have 2 pi iota times even number, then that would be equals to 1. And if we have 2 pi iota times odd number, okay, that would be equals to negative 1. Alright, for the case of unmixed values, we saw that we will get NaCl to be equals to 4 times FNA plus FCl e to the power pi iota H plus K plus L. Alright, so bracket closed. Now this is the structure factor that you get when you have unmixed values, all even or all odd, you can write here. Okay, all even or all odd. Now in one more scenario in which we for example, if we have one more scenario in it, if you want to even add more detail to in it, so what could happen is that we have Na, give me a minute, so we let's say have NaCl that is equals to now let's say if we have all odd situation and all even situation, even into it, let's see what does that one equals to. So if you have all odd, so what happens in all odd situation, we can see H plus K plus L. If all of them are odd, what happens is like we have 3 plus 3 plus 3 for example, so that would be equals to 9. Two odd quantities add up to give a even number, three odd numbers add up to give a odd number again, so we can see that it's 9. Hence this situation will become like that, 2 pi iota odd. So we can write here that we have 4 times FNA minus FCL, because we know that this quantity becomes -1 for all odd situation. Okay, so for all even situation, what would happen is that in all even situation, all even number add up to give always even number. So in all even situation, we will have this one as true thing. So we will have for all even, you'll write that SNaCl is equals to 4 times FNA plus FCL for all even, because we will see that H plus K plus L is equals to even for all even situation. Okay, and it's just like 2 plus 4 plus 8, you add it up and you always get a even number. Okay, even number adds up to give a even number. So this power becomes e to the power pi iota times even, which is equals to +1. Alright, so let's see that what happens if we have mixed values. Okay, we have seen that what happens when you have unmixed values. Now let's see what happens if we have mixed values, and we can see it here, and that is the basic relation. This exponential thing is the basic relation, and let's see that how we can make use of it here. And right, so if we have mixed values, so what happens is that either let's say we have H is odd, even, let's say H is even, K is odd, let's say this is a mixed situation, L is let's say odd as well. Okay, so let us see what happens in that situation. So for the first is H plus K, even odd adds up to give odd number, so we will have -1 in that situation. Then we have K plus L, odd, they add up to give a even number here, so in that case it would be 1. Okay, since it's odd, that adds up to give 1 even number, so e to the power pi iota time even is a 1. And then we have H plus L, H even plus odd number, which is odd number, so that's gonna give you -1. You can say this is +1, which gives 2, and this is -1, which has to give -2, so it's 2 minus 2, which gives you 0, and it's 0 times this quantity, and it's, you know, becomes 0 overall. So we can see that NaCl in mixed situation is equals to 0. Okay, this whole quantity becomes 0, and when it multiplies with this quantity, it makes the whole quantity 0. Anything that multiplies with 0 gives you 0, so that is how this whole thing becomes 0. Now you can try any combination. You can draw any combination, even, odd, even, or whatever you want to do. Like when it's mixed situation, when not all of them are even, not all of them are odd, when that situation is not happening, when they are mixed, even, odd, like that, you can try any combination. They always add up to give this factor to be 0. Okay, and this factor makes the whole structure factor to be equals to 0. So we can see in mixed values, you write here that for the mixed values of H, K and L, the structure factor is equals to 0. Okay, and that is the situation, and that is how we have concluded this video. And yeah, I hope you like the method, and if you have any questions you can ask me in comment section. I'll try to make it as detailed as possible. And yeah, I'll meet you in next video. Till then, take care and goodbye.